Hi guys, lesson 5, Dangers of Radioactivity. So let's go. This is Mary Curie's notebook. Nobody can touch it for the next 1,500 years. It's so contaminated with radioactive substances that to touch it would kill you. You would hope it would be quick, but it wouldn't. It would be unpleasant. So today is all about what are the dangers of radioactivity and how does it damage you. So, I can't remember the page number by this point. I'm losing the plot. So, first of all, the mechanism by which it hurts you. So, we spoke earlier that radioactivity is ionizing. We wrote about it here. So, it's ionizing ability. And it's the ionization that will get you. So, we'll write all types of radioactivity are ionizing. So what do we mean by ionizing? Well, all atoms want to be in an electrically neutral state. Let's get rid of that. So if we take a typical nucleus, I'm not going to draw the protons and neutrons. I might put a bit of red and blue in there. So we'll take a nucleus like so. In this case, we've got 4 protons. 1, 2, 3, 4. So you've learned quite a few times now that for every proton there is an electron. So first shell, 1, 2. Second shell, 1, 2. And we'll just put. It feels weird not putting an orbit in there. So let's put the shell. Make it fit. There we go. Shell 1. I'll make a copy of that, duplicate, and we'll put a second shell in. There we go. So all atoms want to be electrically neutral. They do not like being out of balance, and the only thing that will force them to become electrically neutral is if it's to make a bond and create a full shell. Well, if we take something like an alpha particle, so if you remember, an alpha is 2 protons, 2 neutrons, lesson 3, 2, lesson 2. So there it is, there's my alpha particle. What's going to happen is, with its +2 charge, it's going to come along, and as it passes along, it's going to steal the electron. So this is going to go very wrong. I don't think I can grab that green. It's going to grab it, and it's going to cause it to go into orbit, and it's going to steal it. So this is the act of ionization, and now my atom here has become a +1 ion. It's lost one of its electrons to that alpha particle that's stolen it. So that's the act of ionization. I'll just put 0 plus 0. There we go, feel a bit better about that now. So it creates ions. So we can say radioactivity removes electrons from atoms. That is the definition of ionization. Removing electrons from atoms. Whether it steals them and keeps them, or like with an electron, beta decay, it just knocks them away, doesn't matter. It's still become an ion. Now, why is that a problem? Well, if we were to look down on a typical cell in your body, nucleus, cytoplasm, getting all biology here just for a second, won't happen often, then you are looking at the equivalent of looking down on a city. At any one second, there are trillions upon trillions of interactions of molecules exchanging electrons and making and breaking bonds. So if all of a sudden you are exposing yourself to alpha, beta or gamma, then what you're doing is you're breaking the cell chemistry. It interferes with that chemistry. Now this is happening to you all the time. It's a scary thought. But your bodies are evolved to deal with this low dosage that we live in. So all the time your cells are repairing themselves. And as long as you're healthy and you eat well, a nice broad balanced diet, it helps repair all the damage being done to your cells every second of your life. However, if you're next to a source, a strong source, then it's more than it can keep up with. So if we put an alpha source right next to you, then we have a problem. So the first thing that can happen is it will ionize your cell. Ionize your cell. And the first thing you might know, if it's very low, if it's a very high dose, if you've ever watched Chernobyl, that was brutal. And if you've got a strong stomach and your parents don't mind, I recommend watching it if you can. You will get radiation sickness. The organs that are made of these cells will start to fail in their function. That'll cause radiation sickness. If you, however, you are given a low enough dose not to cause sickness, but for long enough, then if these atoms and molecules happen to be inside your DNA, it might cause mutations. And there was lots of tales of pregnant women having children in the area long after Chernobyl exploded, whose children were stillborn or had mutations that caused them to have very difficult lives. And some of those mutations are permanently written into the human genome and passed on through families. So mutations can happen. And then the classic is eventually it can cause cancers. And cancers are unusual. Cancers are life, but that doesn't know how to switch off, doesn't know how to quit. All living cells have a limit. Because they copy themselves, every copy makes an error, and so the cell tries to correct for that error. Most of the time, if that error is too large, the cell self-destructs. But in cancers, the damage to the DNA switches off that self-destruct mechanism. So the cell just carries on reproducing over and over, and it results in the lumps and the bumps that we all fear. For me, it was 4 base pairs. So out of my 3 billion base pairs in my DNA, just one cell, exactly the right 4 mutated, and that's what led to one cell becoming cancerous for me. And, well, the rest is history. I'm still here. Haha, screw you, cancer. So that is the mutations that it can cause. Now, there's 2 types of ways of being exposed. If we look at Mary Curie's book again, there's 2 problems with this. One is, and I'll put it in bright pink, there is physical material on the book. There was dust, mostly it was uranium and polonium and radium. It's on the book. We call that contamination. So the book is contaminated. The material is on the book. The other thing is, if we were to stand close by to it, the contaminated material is giving off radioactivity. So off comes the radioactivity. If we were to stand near it, then we would be irradiated. Neither are good. So you're expected to be able to quote what contamination and irradiated mean. So we'll put those down as keywords. So we'll start with contamination. Contamination means the radioactive material is on or in you. On or in, we won't go you, it's too personal. On or in the body. And the body can be obviously a human body, but can obviously be the body, in this case it was the book. So that's contamination. The other one we said was irradiation. Irradiation. And that is where irradiation is the emitted, I'm pretty sure I'm spelling emitted wrong, is the emitted radioactivity. Falling upon a body. So you don't want to be contaminated because you've got it on you. That's probably worse. And you don't want to get too close because then the radioactivity is coming off. It's ionizing your cells, and that's causing mutations, or it's causing radiation sickness. Now, there is a really famous example of this. Probably about 12 years ago, maybe longer. A Russian ex-KGB agent called Alexander Litvinchenko. Now, Alexander Litvinchenko was ex-KGB, and he went over to live in London. And he became a minor celebrity because he wrote a book exposing all of Russia's dirty little secrets. And people obviously took a little bit of offence at that. So, posing as a businessman, a Russian flew over on a British Airways plane and decided to meet up with him. And they met in a sushi bar, and they had a cup of tea, and they had some food. And that night, Alexander had what he thought was food poisoning from the fish. He got progressively worse, vomiting, diarrhoea, feeling absolutely terrible. So he was admitted into hospital after 3 days. Now, given that his history was ex-KGB, they decided to give him poison tests. Has he been poisoned in his tea? And the test came back negative, no poison. And they carried on puzzling why this man was slowly dying. Every organ was slowly failing. And they decided, well, could he have been given radioactivity? This was the first time anyone had been assassinated by it. So they held a Geiger counter to his body. So if we were to do this, he was laid down, not looking too great, and they held the Geiger counter to his body. So here we've got the Geiger counter coming off, and they got nothing. So he didn't appear to be poisoned by radioactivity. It wasn't until they took a urine sample. I'll use yellow for this. Don't use yellow very often, but hey. They took a urine sample and they held the Geiger counter to that they then discovered he had massively been poisoned by radioactivity. It went off the scale. And what he'd been given was polonium, P-O-210. Polonium is named after Poland, and it was discovered by Marie Curie. It's an alpha emitter. And this thing was absolutely every cell of his body. He had no chance of surviving this. So what had happened is the Russian businessman was actually working for the government. He'd carried over a very small vial of polonium-210, so small that he went undetected through the metal detectors. He then, while Litvinchenko was in the loo, dropped just one drip of this polonium-210 into his tea. He left, he got straight on a plane and went back. We know this is true because the plane was found, and the exact seat he was sitting in was found, and it was highly radioactive. So we found evidence of it. The sushi shop had to close and be decontaminated. We knew the exact cup. And so if we go, let's have a look. Restaurant. It was a massive story. So the poor restaurant had to be closed for quite a long time. The towel that he used, everything he came into contact with had to be decontaminated. And so why pick alpha, I hear you say? Well, alpha is pretty safe outside the body. It can't get through the skin. But if you ingest it, because it's highly ionizing, it can't get out of the body. It's only going short distances, and that's affecting every one of your organs. It's one of the most brutal ways to be killed. So there was no way of saving him. And he lasted for 3 weeks. And at that point, he told them everything he knew. We know exactly who did it. And funnily enough, the chap who did it went back and he now has a job in the government. And we've been putting in for extradition for that person for a very long time. And they flat out refused to send him. So that's the case that we know of, the only one so far, where somebody has purposely been given a radioactive isotope to be murdered by. But we are all familiar with the mushroom cloud and with what happened in Japan. So in that case, it was contamination from the dust that fell, and that would have fallen for miles around. And then, on top of that, would have been the irradiation carried away by the dust and it settling on things that then people went near. So this is the reason why certain parts of Japan, since Fukushima blew up, and certain parts of Russia with Chernobyl are off limits. The amount of contamination means you will be irradiated if you walk into those zones. I can't recommend Chernobyl enough. I tell you, it's amazing, particularly if you understand what all the dangers are. So that's dangers of radioactivity. A nice cheerful